Okay, after learning the concept of functions, which already we have recapitulated in my last class, today basically we are trying to learn the types of functions. Now, under these types of functions, the first type is called the one-one functions. Now, this one-one function is also known as injection. See, in the name itself, the definition or concept of one-one function or injection is like. What is one-one function? So to understand this one-one function, basically we have to know the concept of domain of the functions. Though already you know, still again I am trying to reconnect you. The domain is nothing but the set of x values. That is the set of independent values which we generally show over here in your left sides. And the range, basically we show the corresponding order image. That is, over here you just see 3, 4, 5 are the range of functions, already you know, and 1, 2, 3 is the domain of the function. See, the philosophically you should say domain is nothing but the inherent potential of a particular things. Maybe a human being may also be a functions if where its potential, inherent potential in the human body can be said or can be thought as a domain. And range is what? Is output, concept of output. That how much using those potential, how much that machine or human being can run or can work. That is actually basically the concept of range. Here actually the output for corresponding using 1, we have got the output 3. So 3, 4, 5, similarly for 2 and 3 you can say 3, 4, 5 are called the range. Now sometimes another concept also we should know that is called codomain. The codomain is something different than range. Here you see that 3, 4, the range, codomain is nothing but all the values in the second mapping, that is y. Here you see 1 has a corresponding image is 3, 2 has the corresponding image is 4, 3 also have a corresponding image is 5. So this 3, 4, 5 definitely is a range for these functions, but you see this 6 has no corresponding domain or f image. Therefore this 6 is not used up. So in the range set, you just see I have not incorporated here, in the range I have not mentioned 6. But in the codomain part I have mentioned the codomain of this function will be 3, 4, 5, 6. Though it is not in the range, it has not got any corresponding f images. So in this way we can understand what is domain, what is range and or what is codomain from a mapping of a functions. So now one clear-cut example of I should say our one-one function is any linear functions. Any linear function is itself a one-one functions. Now, how can I say a function is one-one, particularly from a given function? How can I explain mathematically that function is a one-one function? That you just see. What you can write, suppose anything, suppose y is equal to 5x plus c5, work it over here from here. We first define how can I mathematically explain what is the linear functions, or how can I say it's a one-one function. For definition of one-one function mathematically, we can write in this way: if f of x is equal to f of y, from there this implies or does implies x is equal to y. If we can prove, or first of all I assume that f of x is equal to f of y, and if it implies that x is equal to y, or if x is equal to y, from there if I can explain that f of x is equal to f of y, we can say yes, it is a one-one function. Another way also we explain sometimes that if f of x, if we assume f of x is not equal to f of y, that implies or does implies x is not equal to y. So this is actually from negative sense. If f of x is not equal to f of y, we assume, and if we prove that in that case x is not equal to y, then also we can say yes, it is a linear function. If a function is not one-one, generally that will be definitely a many one functions. That we will explain later on. So first let us try to understand using this logic. If f of x is equal to f of y implies or does imply x is equal to y, I will try to prove using this relationship. Say y is equal to mx plus c, I also can say therefore f of x is equal to mx plus c. We can write this. So f of x is equal to f of y. So f of y, if we substitute x over here, we can say that my plus c. So following this definition, we assume that f of x is equal to f of y. If we can say therefore mx plus c is equal to my plus c. Everywhere we will follow the same technique and we will get the result. So if mx plus c, this c getting cancelled, and therefore mx is equal to m of y. Also cancelled, so we can say that x is equal to y. Therefore, we can say that yes, this function is a injection. That is, each and every values, if I put over here x is equal to 1, for example, and if I know the values of m and c, we can see yes, it has the corresponding images. So in this way, even you will be given also any specific functions. It's an algebraic concept. Say y is equal to 2x plus 5. Is it a one function? So if y, how can we explain it? Or suppose in this way not given, suppose it is given in this way, 2x plus 3y plus 6 is equal to 0. So from here you deduce that therefore 3y is equal to minus of 2x plus 6, and always in that case try to find the value of y, because y is a dependent variable. So y is equal to, you can say minus 2 by 3x minus 2. So if this is a function, if we think it's a function, you can write in this way, minus 2 by 3x minus 2. So therefore in such case, once we develop this as a function, so after now what you can write, you can say that therefore f of y should be minus, just replace x as you have learned in class 11, f of y is equal to this. Therefore if f of, for injection, f of x is equal to f of y, therefore minus 2 by 3x minus 2 is equal to minus 2 by 3y y minus 2 to cancel, and we got x is equal to y. Again we have proved that this particular function 2x plus 3y plus 6 is equal to 0. If we develop this as a function, it's actually linear function, simultaneous equation, or as you know, you can say that in this logic, if f of x is equal to f of y, here we have proved that x is equal to y. Therefore, both these are a one function or injection. So in this way, today I have explained that what is an injection. Our next class I will explain about the subjectivity. But if a function is not one, if we say that f of x is equal to fy, in some cases, suppose f of x is equal to f of y, and if we can prove that x is not equal to y somewhere, then we can say yes, this is not one function, and as it is not one function, it is a many one function. Okay, that we will discuss in our next class. Thank you.